going. So we have given, we made I guess somebody posted something on Piazza that this week you guys should have reviewed a little bit of selection sort. If not, don't worry, it's fine. I'm gonna give you a quick review about selection sort, and because the quiz today is all about selection sort. It's pretty fundamental. It's one of the most important algorithms that you need, and we will go through it together. So yeah, let me check. What is it? So, okay, let me share my screen. We can go from here. Okay, quizzes, debugging. Okay, this one. No. Okay, so it's this one. My slides. Okay. So we're gonna go through the slides first, and then I'm gonna.
The slides.
What? Sorry.
I don't think you're sharing the slides. I see your homepage right now.
Oh, sorry. Okay. That is weird. This one. Can you see it now?
Yeah.
Okay. Good. Thanks. So recitation 2. This is the outline here. We're gonna go through selection sort. We're gonna go through compiling and running through using cline. You guys should be familiar with running and compiling cline, and that's just like the build and the run stuff that you guys have done on the first project. And then finally debugging using cline. I'm also, so on Windows you use cline, right? And then in Linux you use like the terminal to run all your stuff. So debugging on cline is the focus of this recitation, but then I'm gonna also create a video on how to debug in Linux. So you have both skills on both sides, right? You can debug on Linux, you can debug on Windows, it's all up to you. And then the last point, I'm not gonna stress it out for this recitation because we have an entire recitation that talks about test cases. So I'm gonna completely ignore it for this one, and it's gonna make your life a little bit easier for the quiz. So yeah, because we have an entire recitation about test cases and how to create them and how to go through all of them. Okay, so selection sort. I don't believe in definitions, so the best way to explain it to you, to be honest, is just showing a visual to you. Can you guys hear me? Okay, sorry. Okay, for some reason. Okay, whatever. Okay, so I guess we can do the selection sort. So let me get this out here. So as you can see here, these are all the different kind of algorithms that sorts an array, and selection sort is the one here. This is too fast. So what selection sort does is skip back, start selection sort. So selection sort, what is selection sort? Basically, it goes through, right? And then finds a small number and then compares this number with all the different values in that array, right? And then it keeps doing it until it finds something smaller than what you have. And then it keeps that in mind and then keeps going through to compare all the different stuff afterward, as you can see here. So it found the 2. It's gonna go through the entire thing. It's not gonna find something less than 2, right? So what is it gonna do? Is gonna put 2 here, and it's gonna keep going, right? So it's gonna find, it found the 7. Now it's find 5, checking if something is less than 4. Anything less than 4? No. So it keeps going, right? Notice that after it arranges the 4 after the 2, it doesn't start from the beginning here. It goes in, so it doesn't go all the way from the start of the array. The first 2 positions are in some sort of deactivation, right? The active array is starting from position 3, and then it goes and does the same algorithm over and over again to make sure these stuff works. Does that make sense? The selection sorting. Okay, so if we came back to the definition is going to make a lot more sense now. It's the minimum value in a current array So basically it swaps the minimum element to the first place of the current array, shrinks the array by one element, and then repeats the process. And that's exactly what it's doing. It goes and finds the minimum value, swap it to the first one, and then decrease the array by one, and then repeats the process over and over and over and over again, right? So now, I mean, compiling and running, I'm not going to take a lot of your time, but as you know, like running is through this button here. You just run the program. And then when you run the exercise today, you're going to get something like this. Like you're given an array from 0 to 9. It goes 0, 1, 2, 3, blah, 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 but in a random order. And all what you're trying to do is arrange them in an increment order, right? So what happens is, as you can see, first, they are not incremented correctly. There is a lot of like a big number here, and then 0, 0 here, and then a 1 here. There is a lot of problems with this program, right? And another thing that indicates that there is problems with that is right here. It says the process finished with the exit code 11. You usually aim for exit code 0. That means even though the program ran, right, it's still there is a lot of issues that happen, maybe in memory, maybe in other parts that you can't see in your program. So this is how it should look like, right? So this is what you expect out of the quiz today. You want something that increments from 0 to 9, and then you finish with an exit code of 0. Finally, after that, okay, so that's it. That's pretty much it. What are we gonna do now is we're gonna watch a video of someone. Sorry. Yeah, we're gonna watch a video of someone explaining the debugger, C-line themselves explaining how to do debugging using the debugger. And then from there, we'll be able to start on the quiz, and I'm gonna show you how things are working. But before we watch the video together, it's a 5-minute video. I wanna show you again what's the selection sort look like. So for example, you guys see my screen? Am I sharing? No. Okay. So from here, if we have this is an array. Let's say this is an array. The first step you do is you find the minimum. You swap it with the head. So you put it on the left-hand side. Then you find the minimum from the active array. This means it's not active no more. And then you go through, you put it again, and then you repeat over and over and over again. I just wanted to show it to you again. So now we're gonna watch the video of the debugger, and then from there we be able to start debugging the code and understanding how to debug and how to get through these steps. Okay. So let me share. Let me share the thing. Okay, let me share my sound. How do I share sound? God. Does anybody know how can I share sound?
When you're sharing the screen at the top where it has that little boxy thing where you can like mute unmute. There's I can't remember if it's like 3 little dots where you press that thing. You should have share sound.
I did it in the morning, and it's one of the options, but I don't remember how to get it. Okay, let me check. Advanced sharing, maybe. No. Advanced sharing option, right? No. Okay, let me try to share it and see. Okay. Share sound. Okay, I got it. Can you guys see the video? Awesome. And okay, we're gonna watch the first 5 minutes, and then we're gonna come back together and discuss.
In this video, we're going to look at the fundamental debugging features in C-line. C-line has powerful debugging features built on top of Gdb and Ldb. For most
You're unmuted if you're saying anything.
Oh, sorry. Yes, sorry. Yeah, I was talking about. Okay. So there's two different, as you can see on the screen in the YouTube video, there is GDB and LDB. Both of them are bundled. GDB is the one for the Linux machines. And there was a lot of problems in the morning. Some people like their computer automatically register for GDB. So when we go back to C line, I'll make sure that it's bundled LLDB, not GDB. GDB is the one that I'm going to make a video on, and it's a little bit different to debug than LLDB. LLDB is the one that goes with C line. Okay.
Debugging features built on top of GDB and LLDB. For most people, this should all be pre-configured and ready to go. But if not, or you want to use a different build, you can set them up in the Toolchain's Preferences page under Build Execution Deployment. Now note that if you're running on Windows and using the MSVC toolchain, we actually bundle our own LLDB-based debugger for MSVC, and that's the one that you'll find right here. Now if you've ever used a debugger in any IDE before, you'll be instantly familiar with most of the core features. For example, setting a breakpoint, which we can do by hitting Command F8 on a Mac, or Control F8 on Windows or Linux. You can also do that from the Run menu, with Toggle Line Breakpoint, but using the keyboard is a much faster and smoother experience. If you forget any of the shortcuts, you can go to the menu and see them there. Or you can use Find Action to find shortcuts and menu options for any of the features that C-Line offers. Debugging works best when you use the keyboard shortcuts for the commands you use most of the time, so do invest some time to learn them. Breakpoints can also be toggled by clicking directly in the gutter to the left of the editor. And whichever way you do it, you'll see the breakpoint here as a red dot when it's set and enabled. This dot is also your gateway to additional options that we'll come back to in a moment. With one or more breakpoints set, you can start a debugging session by clicking the debug icon here, or from the Run menu, or of course with the keyboard shortcut shown. That's Ctrl-D on the Mac or Shift-F9 on Windows and Linux. The program will now run until it hits that first breakpoint. By default, that's exactly what breakpoints are for, of course, but as we'll see in the next video, there are some more advanced uses too. Notice that now the code is running.
I
the
can't
icon has
hear the
changed into
view.
a little.
I'm not sure if anyone else can.
It's kind of just quiet.
Sorry, are you guys able to hear the video?
Yeah.
Oh, the sound is faint. Okay. I don't know how to fix that. I'm just gonna open captures. All right. I don't know what to do. It doesn't really. I can't control it. Yeah, I just had to put my volume up. Okay. Okay. I'm gonna keep going.
Tick mark, which means the breakpoint is active and reachable. If a breakpoint can't be set because it's not in the current executable, or if debug symbols are missing, then the icon will change to this instead, to indicate that it will never be hit. At this point, all threads, and in this case there's only one, are suspended, and we can examine the state of the process as a snapshot in time. As you might be familiar with while debugging, a debugger tool window pops up, and we can see the values of all the variables currently in scope, including the this pointer if we're in a member function. We see simple values shown directly here. More complex types can be expanded to show their members, and many standard types, like string, have visualizers built in that show you the interesting value at the top level, so you don't have to dig into the implementation. But you can still do that too if you need to. You can even add your own visualizers using GDB or LDB's Python integration, but that's beyond the scope of this tutorial. On the left, we see a stack, and we can move up and down the stack to see variables in different scopes. And if we have multiple threads, we can also switch to a different one here. A nice feature that you may not have seen before is that the variable values are also shown in line with the code, right alongside their declaration. This can be a great way of debugging in context. Once you're at a breakpoint, you can start single stepping, of course. You can use these icons here, but again, do learn the shortcuts. Now there's a few options here. First, we have the usual suspects. Step over single steps at the current level. Step into steps into functions. And step out executes to the end of the current function and out. Unless, of course, it hits a breakpoint along the way. You can also run to any arbitrary line of code, as if you'd set a temporary breakpoint there. But there are some other options too. And these are best seen from the Run Debugging Actions menu. They all start with the word force. But these are not just Jedi mind tricks. Force step over and force run to cursor work just like their forceless cousins, but they ignore any breakpoints along the way. Force step into, on the other hand, steps into a function even if there's no source code available. In this case, you'll get a disassembly view instead. You can still single step through it, or step back out. And finally, for this first video, we'll take a look at exception breakpoints. These allow you to automatically break into the debugger whenever an exception is thrown or caught. To set these, go to the Run menu and View Breakpoints, or use the shortcut shown there. Alternatively, from the Debug Tool window, click the View Breakpoints icon here. We'll look at this dialog in more detail in the next video, but for now, look for exception breakpoints and its immediate child. Make sure it's enabled, and at the bottom you can select whether it will break when an exception is thrown, caught, or
I don't think we need that much information here. The most important thing that we need to get out of this video is what he called them, the usual suspects, the stepping over, stepping in, stepping through. These are the three or four different configuration that you're gonna be using a lot in debugging. Okay, so I can. So I guess let's continue through the slide, and we'll see the most important thing. Let me share my screen again. Okay, so yeah, again, these are the different configurations for debugging: step over, step into, step out. You're gonna get them, so like don't sweat it at the time. You're gonna get and understand them once you start writing your program and using them over and over again. You will understand what each is doing, but they're just a way to get a step at a time. So stepping over, it means step over the function, don't enter that function. I know this function is working fine, I don't want to go and debug it. And then stepping into means I know maybe something is wrong in this function, I want to step into that function and go line by line through to see where the mistake is at. And then finally stepping out, I went to a function and I want to step out, so just gonna execute the rest of the function and just get out of the current function you are at. So with that being said, I have 4 minutes to finish up the lecture and get you guys started on the quiz. So I just want to explain this to you guys and give you a couple of hints so that you can finish your quiz on time. So what is this quiz? This quiz is just using the sort function. But if you wrote everything that you want the sort algorithm to do, it's gonna take like an entire page. It's not gonna look good, and it's not gonna be fun, right? So the way to do it is, for example, what we did here, as you can see on my screen, we have a function called swap, and that function is just for swapping, right? We have another function called minimum, and that function is going to find the minimum value in an array, right? So this is the swap function here, and this is the minimum function here, all of this. And then finally, I use the sort function, and inside the sort function, this is the declaration of the sort function. I do a for loop and I use the minimum and then swap. So I find the minimum, I swap, I find the minimum, I swap, like what I explained. And then print array, this is literally just printing the array to the screen, to the terminal, I guess. And then in main, as you can see here, we have, this is the test array that is given to us. It's 16239 blah 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 blah. So we want to start from 0. We want to increment all the way till 9. So what's main doing is that it's creating this array, right? And declaring this array and then sending this array into this sort function. Sort function takes two different parameters. The first one is array, and then this is n, which is the number of integers we have in that array. And for this case, we have from 0 to 9, which is 10 integers. And then finally, we just printed the screen. The problem that you guys are trying to solve is that I will tell you straight up, like the swap function is working fine. You don't need to mess with it. The minimum function is also working correctly. The print function is also correct. The main is fine. The only problem that you have is in the sort function, in the selection sort function, which is this. This is just a comment explaining what is going on, but this is the function basically, these 5 lines. And the problem that is happening right now, I'm gonna try to explain it. Basically what happens is, remember every time you find the minimum and then you swap it to the head of the array, you go in and you shrink the array by 1. It's not happening for this case. For some reason, if you run this program on C line, you're gonna get 0, 0, 0, number 0, 0, number 0, 0, whatever. And that happens just because every time I'm giving the array back, I'm giving the entire array. I'm not shrinking it. So it goes in, it finds 0 as the minimum, so it swap it, goes in again, but through the entire thing again, finds another 0 and keeps going. So that's the problem. Your task is to get this, copy it on C line, try to use the debugger. If not, if you're having some trouble or something, try to even trace it on a piece of paper if you want. Just try, it's literally 4 lines, and assume that the other functions are working fine. I'm telling you that. And then from there, you'll be able to understand, oh, like I shouldn't be doing that. I should be doing this way because I need to shrink my array. I'm giving the entire array over and over and over again. And that's why I'm getting zeros a lot. So copy this. The first step you want to do, copy this on a C line, run it and see the error for yourself. Start seeing start using the debugger and try to understand what could you change to make sure that it works fine. And then once you do that, the output should be, again, what I told you is going to be from 0 to 9 on the terminal. And once you get the output, let me know, and then you can leave after. So yeah, I'm gonna just give you the next 25 minutes to try and work on this. And around 4:50 or something, I'm gonna give you a couple more hints, but hopefully you guys will figure it out before then. Let me know.
Is there somewhere that we need to turn this in?
Yeah, on Canvas assignment, you will always turn on your projects and quizzes there. You said format? It's just .c file. If you're asking about the format.
Where do we find the PowerPoint with the code?
The PowerPoint, the code is not in the PowerPoint. The code is in the source.c, and it should be on Canvas under files, and then it should be quiz 1 or something like that. Recitation 1 or recitation. The latest recitation you have. It should be okay. Let me figure it out. Yeah, it should be exercise 2 debugging under quizzes _ exercises. In files. So files, quizzes _ exercises, exercise 2 debugging. Don't use it from the assignment. Use it from the files. Sometimes these assignments are linked to random stuff. I don't know. It could be linked from the class before last semester. So things could be a little bit different. So don't get it from assignment, because we don't really update assignments much. we update the files. So go through the files and try to get them from there.